So next, we're going to go back into the more computer science realm. And Porkstradamus, aka Bobby Towers, asked on Discord, a really fascinating thing I heard you say about computer scientists was that they tend to have an aversion to heuristics, and that a big surprise you experienced with Wolfram Alpha was that you found heuristics to play such a large part in interpreting natural language. If you could let me know precisely how badly I've misquoted you. And also, he's curious how, from your perspective, the rapid shift to machine learning has changed the landscape of computing. Are classical algorithms going to become obsolete soon?
Okay, so a couple of things to say. So no, your quote is actually fairly accurate about heuristics. I mean, for many years in designing Wolfram language, I always wanted to make sure everything is very precise. It's very well defined. You kind of know what to expect. Then we started building Wolfram Alpha, where we wanted to have just pure natural language. Whatever somebody says, we got to do the sensible thing with it. And what we realized is that you can't do that in a precise way. Human natural language doesn't work in a precise way. It's full of hacks. It's full of weird historical coincidences. And the thing that I learned, which surprised me, was that heuristics kind of have a logic of their own. Once you have a giant boatload of heuristics, you start to kind of understand how heuristics interact with each other. And it's a different kind of thing than what you expect with sort of precise, sort of axiomatic programming language construction. So that's about heuristics. I mean, it's a very scary thing. You know, when you're doing like unit tests, let's say, for a natural language understanding, you might think, you know, that, I don't know, you have a test that says you've got, 49 cents. What does that mean? It's some piece of, money. 50 cents. Oops, no, that's the name of some rapper somewhere. Oh, no, somebody else. Now, you think it's a modular thing and you're going to test, 25 cents as a separate test. Well, that's fine until somebody comes out and says, now I'm a famous rapper and I've got that name. And then it is bizarrely non-modular and messy in that sense. Now, in terms of machine learning, it's sort of interesting. I think what we've seen is an evolution of machine learning that's very similar to the evolution of things like linear algebra, where there was a time when sort of computational linear algebra came into existence. It allowed computer graphics to develop, et cetera, et cetera, et cetera. There was a period of time when sort of it looked like everything could be solved with linear algebra. That was the 1970s or something. Well, that machine learning is, again, a very useful methodology. It's very convenient for many things. It will not be the full story. Let me give you an example. If you're trying to, you say, well, why do we need programmers? Why not just have, why don't you just, tell the computer what you want in natural language and have it just do everything? So I had an interesting example of sort of understanding that process. I was writing a book about Wolfram language, and I had exercises in the book. And the exercises consist of saying, here's a statement in English. Now write a Wolfram language program that does this. The beginning of the book, when the programs were really simple, that was working just fine. I could write an English language sentence. People would understand what it meant, et cetera, et cetera, et cetera. By the end of the book, the sentences, if I was going to describe a particular program, were bizarre. They sounded like pieces of legalese and patent applications or something like that. They were, full of complicated hair to be able to describe these operations that were corresponding to a program. And I realized that's why we built this computational language. That's why one would have a programming language as well, because it is a succinct way to describe these kinds of computational operations much better than the kind of vague thing that we have in natural language. For short utterances, it's great. You can use Wolfram Alpha, you can type in, you can even do that in Wolfram language. You can type a kind of a short utterance and it will convert it into actual Wolfram language code, a short piece of natural language you can do that with. But anything longer than something short, the tower just doesn't have strong enough foundations and the tower will kind of topple over. There's too much sort of uncertainty in how the language is interpreted and so on to be able to do that. Now, what's happening with machine learning and algorithms is in a lot of what is in Wolfram language is meta algorithms. So let's say you're solving some partial differential equation or something. There might be many different methods for solving that equation. A big part of what we end up doing is trying to automate the solving of that equation by having essentially a meta algorithm which picks between those algorithms. For these types of meta algorithms, we've long used essentially machine learning methods to build those meta algorithms. And that's a very useful thing. If you get the wrong branch in the meta algorithm, well, it's unfortunate, but it's not disastrous. when it comes to the underlying algorithm, it's not something for which you're likely to be able to use kind of the fuzzy machine learning kind of approach. And so, you know, what we find is there are particular applications that we've long used and increasingly use machine learning kinds of things. And there are other places that are just sort of hard algorithms where I don't expect that machine learning will be particularly important or relevant. It's for the, you know, it's like when you're simplifying mathematical expressions, okay? That's a place where there are hard, precise transformations you can make. And if you kind of fuzz those out, you'll just get the wrong answer. But deciding which transformation to make is something that you can potentially do in a machine learning kind of way. And so the thing for us is putting in functions in our language like classify, like predict, like feature space plot and so on, that are underneath using machine learning to do things, but which are sort of elements of the language and can be called in other places. That seems to be a pretty powerful thing to do.
Awesome.